Welcome everybody to Rise. Most of you guys have been here before. We meet every month, talk about security topics, and try to have a little beer, snacks, or something like that, and enjoy some networking. We got Aaron doing Bloodhound tonight. In June, I think I'll be talking on cloud security. Haven't set a location for that yet. And July, I believe Tyler, of course I forget his name now. Tyler's going to be talking about starting pen testing. So welcome everybody. Thanks for coming out. Thanks to ABS and Tony for hosting today and providing snacks. She went out on short notice and got us loaded up with snacks and beverages, so really appreciate it.
Yeah.
Did you want to say
yeah, just for those of you that I haven't met before, I have worked with several of you before, but just ABS Technology. We're based out of Virginia Beach. We have locations in Virginia Beach, Richmond, Roanoke, and West Virginia. We are everything technology. We do structured cabling all the way up into wireless, route switch, data center, security, professional services. So pretty much any need, we have engineers on staff that can come out and help, and you know, just procurement type items. But love to have the chance to talk to you guys, and appreciate the opportunity and have fun.
Thank you. Well, perfect. All right. Well, thank you so much. I appreciate the introduction. But so today we'll be talking about Bloodhound, which I guess we'll get into it a little bit here. But first and foremost, wanted to say that the opinions expressed in this presentation are my own and not my employer. The other component is that I'm actually kind of more of a Linux guy. So I'm learning Windows in this process. I'm probably where maybe I hope some of the other people are at, but if you're better than me, awesome, please correct me. That's basically what I want. I may be slaughtering some of these concepts. Additionally, no real data was used to make this presentation. It doesn't represent an actual network. It's a generated network, and it caused some problems for me, but I'll make sure to highlight what did highlight value in a real network. And then down at the bottom right, there's some statistics about the network that was used. So when you're kind of looking at graphs, looking at things, I want you to keep in mind that this network had 391 users, 270 computers, and then there's like 148 groups. You don't know what that is? Perfect, we'll get into that. That's not a problem. So what we'll be going through today, kind of what I wanted to talk about is obviously Bloodhound, but before that, I really wanted to get into like there's some initial concepts and understanding why we're exploring trust relationships. What is a Microsoft Active Directory? Some little bit. I'll probably fly through those. If you want to stop me and ask questions, do feel free to. Yeah, we can. This is sort of an interactive thing if you guys want it to be. Then we'll get into Bloodhound, demos Bloodhound, and then hopefully get you guys primed for getting started on Bloodhound. I will say that this is I'm treating this as more of a defensive view on Bloodhound, and Bloodhound I perceive is a tool that's been generally used or at least publicized on the offensive standpoint. And what we're trying to do is make this a defensive tool. It's a very powerful tool. It's really cool. And so from my perspective, this is really what we're trying to do is make this defensive, understand our defenses and go from there. So I may gloss over some of the capability of, hey, you can do these really cool things if you plug it in this right way. What I'm really getting to is how can you use this in your home or in your work network, your corporate network? How can you have this as a capability? So getting into this. Microsoft Active Directory, you guys probably understand it. It's just a way of organizing all of your enterprise assets. Really what we're getting down to is understanding like how to control our computers and what they have access to. We have users, principals, and what we're getting to is that we're identifying trust relationships and in order to have a fully functional network. Now the hard part about this is when these trust relationships go too far and break the concept of least privilege. And that's really what we're trying to do with Bloodhound, is to explore how are we abusing least privilege, how are we giving too much access, and which ways can we tighten it down such that we can still have the same functionality, still have the same capabilities, but be able to secure our network. So Microsoft Active Directory, this is really what we're studying. This is just basically organizing these IP assets. Pass the hash is another major concept. If you guys haven't heard about pass the hash, I'm sure you guys have. But it's a interesting little, it's sort of a feature is the way I kind of think about it. It's a feature by design. Really what we're going to call it is a vulnerability and exploit, a way that an adversary can exploit a trust relationship. So if you consider the normal login process, a user goes to the computer in the morning, they type in their password gets hashed. Awesome. Hashes we like. We don't want to know what clear text credentials are. that password, and actually that password in some systems, or just the hash, gets stored in the credential store that's on the local system. So it's something that's in memory. Now, when they go throughout their day and they access file shares and other enterprise services, that hash, when the user goes to log in, user goes to use that resource is actually saying, hey, who are you? And why are you, do you have access to this resource? And it will pass that hash, take that hash of the credential store, and send it to that enterprise resources so that that user can authenticate to that server. Now, adversaries can do the exact same thing if they were able to dump that credential store. So if they were to say, if an adversary were to compromise a user's laptop, they could use a tool like Mimikatz to dump that credential store and then act on behalf of that user, or just like that user, impersonate that user, to access all enterprise resources. Now, the fun part comes into when if that user has the capability to log into other systems. So what will happen is that an adversary will say, get a beachhead onto the network, compromise one laptop, dump the credential store, and then move laterally across the network to another system and do the same action until they get to what they want to get, or to get to where they need to go to. This is just basically, there's an initial compromise, they dump a credential store, and then they act like that user moving across that network, and they can dump credentials along the way and gain additional credentials, gain access to additional machines so that they can further compromise the network. So really what we're trying to do is defend ourselves against that. And that's what Bloodhound is designed to show you, this sort of thing, how we can abuse this trust relationship. So now we get on to Bloodhound, or basically how to make pen testers work for their money. I was hoping Tyler was here because he was basically saying he likes Bloodhound because it makes his job a lot harder and a lot more fun. But all right. So what is Bloodhound? And it's a graph exploration tool, which is, we'll talk about graphs, what that actually means in a bit. And its sole purpose is to reveal hidden and unintended relationships. Now, these hidden and unintended relationships are things that we might call nested groups, as one of these obvious concepts. Ultimately, it identifies complex attack paths. So the idea, it identifies complex attack paths, and does it have some pretty cool baked-in queries to show you that. And you can also ask Bloodhound some questions to say, hey, this is what, I'm asking, from this perspective, what does the user have access to? The cool part about Bloodhound, and I think we often say Bloodhound and what it's using, and that's the data analysis. There's another component to Bloodhound, which is this one, which is SharpHound.
There is?
Oh. Can I answer the question?
Is there a question on the line?
All right. So SharpHound is basically a data component, or a data collection component. Really freaking cool, actually, because there's actually a lot of stuff that it goes into the network and it pulls a lot of detailed information out of it, and it's things that you just can't really get out of LDAP and other utilities. They're asking fairly unique questions. They're doing it really cool, and they're constantly updating SharpHound and Bloodhound and how that all works. So relationships, graph theory, these are all components that are within there, and it really gets down into how we express what an actual network is and what are the components. So we've boiled down to what a graph is. It's basically a network, or some other thing you define by vertices and edges. Vertices are really the users, groups, and computers, and edges are the how can I get from one of those things to the other. So basically, we're really trying to say, what do I have, or what do I want to have, and how do I get there? That's really all these graphs and that's all this graph bits is all about. Basically saying, what assets do I have, and how do I want to get there? And that's really the asset and the edge to get to another. The vertice is the asset, and the edge is the how do I get to that to the next asset. And if you're wondering, like, okay, right, how bad can this possibly get? Since this is the first actual component of a screenshot that I have on this on the slide deck, how bad could this potentially Bloodhound reveal some of these complex attack paths get? So on the right-hand side, I do have domain admins that is there. That is this sort of component here. Has a nice little jewel on there. And from an earlier slide, we'll highlight that domain admins is kind of considered the crown jewel of your network because they can manipulate domain assets, meaning they can add new users, change passwords, that sort of thing. So this is our crown jewels. We have a couple of things that are leading to it. All of these things that are here. So up in the top, or up in the component here, we have a user that is a member of domain admins. That's normal within a network. We also have some other users that have other capabilities, and we'll get to what these edges actually mean in a bit. The edges are generic all and right tassel. These are complicated. I actually had to look these up when I first started up Bloodhound, but we'll get that. These are all ways that potentially like say this user is a member of domain admin, so they're obviously part of that. But These other ones have more complex attack paths. Now, if we were to unroll part of this sort of capability, this attack path, we then get into, hey, it gets a little bit more complicated. We start to see, hey, some of these groups have nested groups, right? So Exchange Organization Administrators is actually a member of, or it's actually somehow associated to Exchange Recipient Administrators, which is then associated with domain admins. Maybe that's unintentional. Maybe should Exchange should Exchange Organization Administrators have access to domain admins? That might be something worth exploring. But let's unroll this even further and see how complex it could actually get. And so this is, I will say, an example network, but I will say on a live network, it looks similar. It looks crazy complicated. There are a lot of pathways to domain admins. And that's just from running a network that has some people are just not exactly looking at that. Bloodhound brings that all to light, which is rather cool. So let's dive into actually getting to trying to use Bloodhound. And first, want to start off with how bad guys or adversaries, pen testers, however you want to talk it, might actually use Bloodhound to figure out how to exploit your own network. So let's assume for a second that a bad guy, adversary, compromises a random node. In this particular example, they're exploiting desktop 8, internal.local. They're able to get system privileges on that through some way, privilege escalation somehow. They're able to run SharpHound, which is that data collection utility on the network. They're able to pull in as much information as they need to, and then they take that database generated by SharpHound and they upload it to Bloodhound, which is a tool that they'll have sitting on a local system. They will enter a mode called pathfinding mode. Basically, they just say, I'm here and I'm at desktop 8, and then I want to figure out how to compromise domain admin. They hit the little play button on this thing here, executes a query, a cipher query, and you'll actually see, hey, here's basically how we get from point A to point B, and we're going through all of these hops. Meaning that desktop 8, and if we actually walk through what that actually is, desktop 8, that internal.local, has a session, has a user on that particular system, and if we had Mimikatz, we could dump that user's credentials and impersonate them. That user happens to be a member of Contracting J, and that Contracting J group is listed as an administrator for this particular system 27 or 24, which happens to have a session for this other person here, B.S. Hoffner, who is a member of domain admins. That's not something you would normally look at your network and understand like, hey, this is, I can see this actually happening. This is not a thing you would normally see clearly. And this is a simple mode which you can say how I can get from one random node on a network to how to get to a crown jewel domain admin. So the next question is, and this is the part where I say there's sort of a small capability on the defensive side, or I wanted to show a little bit on the offensive side, but really what I wanted to focus into is how to defend yourself against it. So, hey, that's actually the next slide. All right, I was thinking the right thing when I was generating things. So this is a wall of text. This is sort of the title slide into like getting into more components of this. But really, the way that you defend your network is through a few mechanisms. And first and foremost, it really should start with, hey, what's your high value assets? What should I be protecting? How do we prioritize this sort of capability? And we'll basically say, hey, domain admins are important. Additionally, enterprise admins are fairly important. Backup operators, VMware, basically your VMware admins, because they can manipulate the things within there. Exchange admins, SAN admins. Go through that list. Go through, try to understand what are the component group of the high value groups within your network. Then understand, hey, what people are part of these groups, what people are performing these functions. They'll be your high value users. Those are the people the administrators within your network. Additionally, understand the computers that are also important. So these are the actual, like, what are the domain controllers? What are your exchange, like your exchange systems, these kind of things. You want to protect those as well. Start looking, when you explore these, look at them with the goggles of what could be misconfigured. Is there a lot of local admin privileges? Is there unintentional nested groups? These kind of things. And when you're going through these, also Bloodhound has baked in queries to actually help you with all that sort of stuff. To basically say, hey, I want to see all the top 10 administrators on the system, or I want to see all the top 10 logs and admins. I think is one of the queries. I'm trying to draw those off the top of my head. All right. So the next step of that is to try to make some change, to educate and educate some folks to say, hey, here's some bad stuff on the network. Here's some things I've seen. Is this intentional? Is this part of it? Or is there something that we can do to make a change out of it? So really, it involves just saying, let's screenshot the graph and say, hey, this looks kind of bad. And you can actually go through an attack pattern that looks a bit like this. And you can say why it looks bad, or say why this looks bad. Additionally, one of the things that we're trying to move towards, what we'd like to move forward at where I work, is the numbers portion, the metrics portion. Can we use metrics to capture what we're doing, what is our current baseline, and how can we improve? Or we can also see if we're trending worse. These sort of things are where we're wanting to move forward. Additionally, sort of a nod to how Microsoft tried to acknowledge pass the hash is that they produced a bunch of documentation saying, oh God, by the way, guys, we built this system that's Active Directory. We set, you're paying a lot of money for Active Directory and all these consultants and that sort of thing. By the way, here's the right way how to do it, which I haven't seen an organization do that, but then again, I haven't seen too many organizations that follow this to the T. But they have a set of best practices, which is the tier model. One of the components of the best practices is the tier model, which we'll get into that in a bit, but that's another little bit. So let's walk into understanding some of your assets. So like in this particular example, we're inspecting a group that is research.external.local. And actually, this might be helpful if I go ahead and drive into the actual thing here. Let's not do that. Fire up this Bloodhound. Now, see, my screen sharing is paused. I got to make sure I'm sharing this bit. New share. No, I want to do new share, and I want to share this guy.
On the other side of the parking lot.
I don't know. I might have to go back. All right. So I have just a basic Ubuntu VM. I use a Docker. There's a Docker. What do you call it? Basically, there's a GitHub project that wraps Bloodhound inside of Docker. Makes it super easy to fire up and down. So I have a blood example is one of the things that they follow through for that. So firing up the blood example thing here, and we'll actually fire up Bloodhound. We'll talk a little bit about that, and I'll jump to the research at external.local. So, and it'll take just a second to log in. I really love Docker, but it made this whole install process fantastic. I can kind of wipe and rebuild fairly easily. Bloodhound is backed by this Neo4 database. We'll get into that in a bit, but all right. So I have a sample screen of Bloodhound here. Top left-hand side is sort of my search area. It gives me some particular bits of information. So that screenshot earlier about what was contained within the database is all contained here. So you can again see that 391 users, 270 computers. I want to drill that into your head for the time being for those little bits. We also have some node info we'll dive into, some basic queries, and we have some data manipulation elements and settings info and little bits over here, but I'll let you explore all that. Let's go to research external.local, because that's the group that I wanted to explore. So nothing exciting yet, but if we click on research.external.local, we can get some node information from this. And the node information is actually kind of cool. It's kind of like like these are the sort of the key performance indicators, the metrics that other people the things that you might actually care about. Some of those may not mean anything, but sort of take a look at it, understand it, and try to understand, does anything jump out at you? So from this, we can see that research.external.local has 17 direct members, and we can actually go through and click on the 17 here, and it will say, all right, let's go ahead and bring all these guys up. If we try to zoom in, this is why I brought them out, because touch that does not work. We can see research contains a few other groups, which is research and development A, B, C, D, goes all the way through G. Research also contains information technology groups. That may be something worth questioning. Why is that actually happening? Additionally, it contains 4 users. Nothing too exciting yet. But if we actually go through the points and say unrolling the members, this gets a little more complicated. We can start to understand some of this group relationship. And we can start to see, hey, there's additional users that belong to some of these groups which belong to research groups. We can start to see some of the complex things that are forming here. Now, that's not the reason why I brought up research at external.local. The other point that I wanted to make was that there's a list of first-degree local admins, meaning that this research at external.local is listed in the local administrator group within 28 systems. Keep in mind, this network only has, and we can go back to this, the database info, has 270 some computers, meaning this single group has admin rights on 1/10 of your network. That might be a little too much power. Maybe, maybe not, but we can also dive into further and take a look at what these machines are and start to question that. If I can actually use the interview, well, I can, yeah. We start to actually go through some of these lists. We can start to say what these machines actually are. Some of these may make sense, some of these don't. I'm not sure, this is not my network, this is an example network, so there's really no context behind this, kind of what you'll take it as. The harder part about this is the derivative of local admin rights, meaning what assets can I get to from these guys? So given that you're compromising 1/10 of your network, you have local admin on 1/10 of your network, it means I can pass the hash on 1/10, or do a credential dump on 1/10 of your network, which means I can also potentially pass the hash with additional with all the users that may be on other systems. So if we click on derivative of local admin rights, we can start to see a complex attack or complex graph actually starting to form. We have our initial 28 machines that are listed here, and then we have additional machines that say, you can see with the edge saying has session, meaning that this user can be compromised because they have a session on this machine, and because we have a start with an asset, the research at external at local, we can essentially compromise or get to this machine easily, run Mimikatz, and get any user that's on this machine, which includes this user. So the other fun part about this is that we can start to take a look at this a little bit further and see if we go through this list, and actually it's the very bottom one, the more complex portion of this chain. One of the users that is on one of these systems, so that's A. Brooks, has a session on this desktop 40, which means that, yeah, this user is a member of domain admins, which means I can essentially reach domain admins as well just by having this research group. A little bit complicated, sorry, I have to probably follow all the lines better, but so some of this derivative local admin rights, I should probably say, incorporates has session. It's one of these things where it is potentially misleading. They don't have direct local admins, but it means that they can derive it, meaning they can get to it eventually. So that seems like a high number, given that there was 270 some systems on the network. That 264 is a very big question mark, and it's one of those things where you should probably start asking questions in that case. All right, any questions so far? We'll dive back in, explain some more. We'll jump back to jump back to this back here. All right, now I need to get to Chrome, back to here. So, all right, basically what I was trying to do in a slide deck, just in case the whole Bloodhound thing didn't work, I had an example that was back here. All right, so Microsoft Active Directory tier model. And this sort of model is basically saying, I need to provide fodder for cat hash to hash. That's the way that I think about this. It means I need to have containment zones so that if somebody were to pass the hash, they're not going to protect what Microsoft cares about the most, which is domain admin. It's also what you should care about the most as well. So the tier model basically identifies 3 tiers initially. I encourage you to identify more or identify these containment zones. But initially, sort of thinking about this, there are 3 zones in which you should consider. The 0th tier, which I probably should have made that tier 1, but trying to match the model that they have here. The tier 0 is basically, that's where your domain controllers live. So a user that is a domain admin should only log into workstations or just the domain controllers that are associated with that tier, meaning that there is no sort of user stations that are on there. This is all for administering just the domain controllers, and that's it. The domain controller, or the domain admin, should not be logging into servers, should not be logging into workstations. They do have only as required by role. Just try to restrict that down as much as possible. Try to restrain, you should try not to use domain admins gratuitously on tier 1 and tier 2. Similarly with tier 2, you're not supposed to, that's basically your enterprise application level. So that's where your servers and applications should live. Those folks should not have any sort of administrative credentials or user credentials for your tier 0 or for tier 2. Does that make sense? Basically, we try to segment our network. We try to segment our users so that they cannot cross these boundaries. They cannot log into the systems that are across that boundary. What we're trying to do is limit the spread of credentials. We're trying to limit the spread of the credentials so that pass the hash is a thing that doesn't exist in this network.
So we shouldn't give service accounts domain admin.
Correct. Yes, absolutely. Yeah, that would be a horrible thing. I'm glad we don't do that, but that would be a horrible thing to do. So, and initially, it's like your bottom tier is your workstation, and this is where I think the area that has the most exposure and the area that's kind of considered the cannon fodder area. The idea is that you're trying to contain an adversary within one of these containment zones. Okay. So, ciphered metrics. So, I kind of skipped over this. I did actually have it there. All right, Neo4j. So Neo4j is a nifty little database. That's a graph processing database. It's really cool. Not a language I've ever seen, or there's nothing that I've ever seen before. It's not like a relational database. You're not writing SQL. You write Cypher. Cypher is the language that queries Neo4j, which is your graph processing database. And if that is kind of confusing, it's not a problem. A guy named Captain Jesus wrote an intro to Cypher for the specific purpose of Bloodhound. So thank you, Captain Jesus, for writing that intro to Cypher, because it explains it actually relatively well. Pardon?
Right.
All right. So the cool part about Cypher, this I try to sit down and wrap my head around this. The Cypher can be written to return not only graphs, which drives the Bloodhound application, but it can also be used to generate numbers. Kind of like what we saw for like, hey, there's 17 users that are in this group. We can also use it to count interesting things about your throughout your enterprise. So metrics, those are good things. I think that's good because we can snapshot with SharpHound. We can snapshot the database and we can generate some metrics about that. And then later in time, we can do a similar collection with SharpHound and and then generate metrics for that database. And we can compare those two. That means power. So what are these metrics good for? Just what I just said, security trends. We can also do another thing, which is we can quantify a change and how that can impact security. Because Bloodhound allows you to edit edges. We can say, hey, what if we assume for a second that this user doesn't have access to this, or this user is no longer part of this group. We can then also make edits to the Bloodhound database, or we can make edits to the database, and then we can rerun these metrics, and we can quantify what sort of how a change could impact security, which is kind of cool. And so that's not an original thought. There's another wonderful person named Waldo. So these are two of the 3 developers of Bloodhound that are talking about this. But Waldo has already started talking about this, and he's got a wonderful series of blog posts called the Adversary Resilience of Methodology, which is basically how to make your network resilient if there is compromise. How do we make sure that if there is a compromise, they don't own the entire network? And he suggested the following metrics below. They're not the ones that you have to drive yourself by, but they certainly make sense. And the metrics that he's suggesting are users with path to domain admins. So of all the users on the network, how many of them have a path to domain admin? And then computers with path to domain admin. Similarly, we're asking the same question about computers. So if I compromise a computer, how many of them have path to domain admin? And then what is the average path to domain admin length? Now that's sort of a weird one. Average path length. So average path length. That means the number of hops that they have to go through to get to domain admin. Which I equate to the amount of work that has to happen to get to domain admin. So in other words, we want these percent size flow, basically saying we want to limit the amount of users that have a path to domain admin, and we want to make this average path length higher, so that they increase the amount of work that an adversary or pen tester has to do. Interesting fact, and I'm wondering if, I think I've shared this with the AAP folks. Locks. If you look at physical security controls, like locks, they have a time element to them. So you could buy a 30-minute lock, or you could buy an hour lock. And the cool part about that, that's basically using like block picking techniques. That's how long it would take an adversary to break that down. And so when we start relating our network into path lengths, or we start relating it to time, we can start becoming predictable, or we can start doing additional sort of elements to our network. We can start measuring our security. So, and it's sort of analogous to the physical how locks are done in terms of time. We can start making guesses, educated guesses for how could we project how long it would take an adversary, a bad guy, using Metasploit techniques on the network. How long could it take this network if we can start understanding path length? Kind of fun stuff. Anyway, that's the side topic.
I have a question on you said you could modify the database for metrics. So that's
Yeah.
modifying it and then running it again to see what that change is.
Absolutely.
Without actually making it.
Absolutely, yeah. So let's show that real quick. So now the fun part is, so I had a different line of work. So I will say this virtual machine, if I get into snapshots and show you, there's a work route that I had, and then there was a Bloodhound demo route. I started making edits here so that I can expose Neo4j. I'm not set up for something to actually do that. It requires changing Dockerfile a little bit. I probably should have started that this route, but anyways. In other words, I'm not set up to show Neo4j today. But I can show you at least how to edit a route, which means if we actually go through and say, into this particular one that's particularly bad, I can go ahead and say, right mouse click on that edge. So highlight it, right mouse click, and say delete edge. And we'll say, yeah, go ahead, that's totally fine. From this, I'm going to rerun this query. Oh, it actually popped back up because there's another user that has a session on another computer. Might be playing whack-a-mole here. Try this again. I am totally playing whack-a-mole right now. And you might feel like this way through the network. Okay, this is getting bad. All right. I'll for now. This is an example network for web design. We're just going to leave that there. But you see the idea. We can start playing with this stuff. And that live edit, or that will change the Neo4j database, and you can access that through, it's basically like through a web browser, kind of like a pseudo IDE slash, it's basically kind of like a little IDE, but it's web. So you can then just go in there, run all your Cypher commands. And the Cypher bits, it's in that bit. There's a great resource for it as well. So, all right. Any other questions?
One question on that, since you're playing whack-a-mole, is it not showing them just to keep the screen less complex, or is it only showing like the easiest method?
That's a good question. So that gets into the, what is the underlying query that's being performed here? And I've dug that out for the basic inquiries, try to get to that. And there's probably, the best explanation is probably understanding that query and then figuring out why it's doing what it is doing. I don't know what that answer is, but the right answer, the route that I would take is when you get to node info, there's baked into the source code of this, we can actually start seeing what is this query actually doing. And when we understand that query, we can then see what that roll out of. This is certainly not, the graphs that they perform here are not the most complete of graphs. You can perform a complete graph and see what all the connections are. And the best way to describe that is spaghetti. That is, when you actually get to the spectrops, like this, the spectrops guy, Waldo, when he's talking about the completeness of the network, he actually has examples of that looking like spaghetti. If we actually jump into that. And that's how he's saying users with path to DA, he's executing that query and then going back, taking a step back and then doing the count of that. Which is kind of cool.
Another quick question.
Yeah.
Is it possible to script this? Like, could you set up a cron job to run weekly to pull down metrics and then?
That's where I want to be. Yes,
Okay.
yes. That's precisely where I want to where I want to be with this tool in the future. It's to get it, and because this is a Windows tool, let me get back to just so I'm sharing the right thing so that people who are recording this, looking at this later, don't get too confused. All right, so task manager, I think is the task scheduler is the Windows equivalent to the scheduling bits. As long as you can schedule that, like SharpHound can do that collection via task scheduler, and the idea is that will ship this database to a sort of a centralized, secure repository, because I don't necessarily want to be sharing all this stuff out throughout the entire enterprise. This is something that I should be treated sensitively. It seems rather important because it basically draws a map for a pen tester and adversary to break the network. But yes, you could do that component. The part that I haven't figured out yet is how to automate it or automatically load it into Neo4j, and then I can do my manipulation. So I haven't figured that part out yet, but there's got to be an easy answer for that. I just haven't gotten to that step yet. So good question. I don't have a good result, but if you do figure it out, I do want to know. Yeah.
It's something to keep in mind there too, is where you're running it from and who you're running it as you'll get a different perspective depending on that.
Right.
Oh yeah, I have a slide for that.
Oh, sorry.
That's okay. It's all right. Steal my thunder, man. All right. Any other questions? Yes.
You kept mentioning a user has a session on this machine or a session on that machine. Does that mean when you run it at a different point in time, when those sessions have expired, you'll get a different round map as well? So
that is absolutely correct. So the session is a point in time, what's currently on there. The fun part is, so the way pass the hash works, this is where I'm starting to falter in terms of Windows. We understand how pass the hash works is that some of those credentials could even still exist on that system while, even if they didn't have that session there. So there are techniques within SharpHound to say, I want to stay alive, stay open, and I want to look for additional sessions that are added. Meaning instead of taking a snapshot in time, I could then represent, I could do a longer capture and take a snapshot of over a business day, or over a business week, or over a business month if I want to. Additionally, with SharpHound, we'll get to that in a bit, but you can also then merge databases together relatively easily through just uploading all of what you have into the Bloodhound GUI. So I can say, I can grab multiples of these SharpHound databases, throw them into Bloodhound, which loads it into Neo4j, and that all merges together seamlessly. In other words, I can do point in time, or I can do point in time snapshots. I can do just sort of a long time sit and listen type, sort of data collection type elements. And then I can also merge databases that may run from multiple perspectives on your network. Hopefully that's clear.
that sounds like spaghetti, but
Yeah, well, yeah. I'm still trying to wrap my head around the site. Yeah. Okay. All right, so I'll keep on going. One of the cool parts about this is one of the things, because this is where I'm not a Windows guy. I understand a little bit about Windows and how that works. And I do understand what it means by member of, has session, admin to. Those are very clear things. These are things that if you're even somewhat familiar with Active Directory, somewhat familiar with Windows computers, you should understand these concepts of, I am a member of this group, or I have a session on this computer, meaning I'm logged into the computer, or I'm an admin to the computer. There are other potential edges, so how I can get from point A to point B, that I didn't understand whatsoever. And these are what does it mean when I have, when a user has, in this particular case, organization management has generic calls to domain admin. That makes no sense to me. And I had to go through and basically understand what that actually was. It turns out, to my surprise, Bloodhound had help for that. So these guys wanted you to understand all this stuff so nicely. I think it is. If you right-mouse click on an edge and say, hey, I need some help on this, it will bring up 4 perspectives on what this generic all thing actually means. I can get a high-level understanding, just by the intro, a high-level understanding of what that actually is, how to use it, how do I secure it, and, oh, by the way, here's additional resources on perhaps who developed this thing, or maybe there's how-tos and actually how do you abuse it. So not only do they basically try to say, like, they try to help the attacker, and I guess what they're trying to do is provide documentation for both the attacker and the defender of the network on how do I either break into this, or how do I abuse this, and how do I secure this. The other thing worth noting is not all edges that you encounter lead to any sort of badness. That's another sort of fallacy with this sort of thing. We're going to start looking at this. And one of the ones that you might see down here under the special section is can RDP. Just because I can RDP to a computer doesn't mean I can necessarily exploit that computer. So take these sort of complex attacks with a grain of salt, understand what they're actually doing, make sure to kind of look at all the little nuances and details. It's kind of the important part of all of this. SharpHound. I wish SharpHound had an icon, so I just Googled SharpHound. But I think he's pretty good. All right. So SharpHound, I just talked about that a little bit. That's kind of what we just talked about. It's the thing that feeds Bloodhound. It's the thing that collects all the data and pulls up the network. It has an extreme number of options, and it's confusing because one of the things that we encountered is that, so if you just run SharpHound by itself, it does a great job of doing data collection and it populates the graph. But it turns out, hey, that's not everything. But if you pass the all flag, it doesn't actually collect everything. Oddly enough, all does not collect all. So you actually have to pass it Bloodhound collection method all GPO local group logged on. So basically, what ends up happening, what you should do if you're looking into doing this data collection piece, the best thing I can tell you to do is go read the flags. Just go read it. If you're doing a SharpHound collection, go read just a little bit of documentation. It's not much. Go ahead.
Does SharpHound trigger antivirus?
Yes, it does. Yeah, we found that out. Yeah, it totally does. Yeah.
You would have to allow it if you wanted to.
Correct. Or work around it. Yeah, you do have to. It will trigger antivirus. Good question. I should have thrown that up in there.
Are you talking about Windows Defender or whatever as antivirus?
We tripped up on our local solution, so that's the only one that I can attest to. So I don't think in that context we had Windows Defender turned on. But it did for our local AV protection. It did fire.
We could always throw it up the virus total and
is that the one that triggers all the ones that it triggers?
Yeah.
Have you tried that yet with PlanBase? Since you said you're Linux guy.
No, I haven't. I have not. What?
PlanAV is actually on virus total now too.
Really?
Yeah.
Since when? I didn't know that.
Last one I went and looked at, I said, hey, look, there's PlanAV. So I thought that was kind of cool.
So yeah, we'll check that.
Yeah.
Check it out. Yeah. SharpHound.exe, drop it in, keep the hash. What? How bad is this file? Oh, look.
Hey, still 50%. I mean, shoot.
Yeah. So yeah, it looks bad. Yeah, it does look real bad. So good question. It is tools. Yeah. So, all right, go back to room share.
I guess too, if you own the system, if you've already compromised the system too, you control that system. So
Yeah.
it doesn't, yeah.
All right. So, yeah. I should not have taken a bite to eat, I'm sorry. All right. So, what one of the guys said for us, our pen testers, so we have the company that I work for, we we did have pen testers come in through, and they rolled in, and they one of the first things that they did is they ran Bloodhound, ran SharpHound, clicked a bunch of data, and figured out the pathway to domain admin. And so, in sort of the remediation stages, we were talking to them about Bloodhound. That's kind of what spurred this whole presentation. And one of their bits of guidance was, ironically, hey, when you run this thing, run it as domain admin on your domain controller, which seemed kind of ironic to me. And so I was like, doesn't that sound a little weird to you? Like, and their insight, which I do think is worth noting, is by design, all hosts have to talk to your domain controller. So there's somebody has session has to reach out and touch a computer, and so by design, that interaction must exist from the domain controller perspective. So if I run this from perhaps say the HR VLAN, that which may be segmented from the like the InfoSec VLAN, right? We may have differing perspectives for when we actually do our Bloodhound collection. So by running it onto the domain admin, we're kind of running it at the most central point of the network. And by design, the domain controller must have perspective, or must be able to see all the machines in the network. So there is some sense in that. Do run this on, or do run this on your domain controller.
From a pen testing standpoint, though, it seems kind of counterintuitive.
Yeah.
In order to find the path to the main admin,
I will say, even from when we ran it from a local machine on our system, it gets a lot of information, more than enough. And it's basically what it will definitely capture is all these default edges, and it starts getting questionable on, but it won't capture all of these. It'll definitely capture member of admin 2. Those are ones that it will capture, most of those. Has session gets a little funky, and then the rest of them I'm not totally sure on what is allowed there or not. But it does get enough to understand a pathway to compromise, and remember there may be multiple pathways to compromise. So I don't know. Anyways, this is where I start failing and saying we should use this on the defensive perspective. Anyway. So, all right, demo Bloodhound. This is the part that I'm most scared about because things will probably break. All right. So that's bad. All right, let's kill that. Bloodhound application. I guess it's about full that we can get. One of the first things that I immediately saw value on our own network, is some of these pre-built analytics or pre-built queries. These pre-built queries, I have a lot of wonderful little bits, and they basically say, hey, what should we care about? I will also say this example network, and I don't understand why, it breaks on some of these queries. The one that we found the most value is the shortest path to high value targets, and that one does not work. And just to show you what happens, I will click on it, and it will be like, hey, no data returned from the query. I'm not sure why, but if we actually go through and say, if we do this, what's similar, and just say we're focusing on domain admins. So let's go ahead and say domain admins. And if I grab this group, I have a few options. If I'll click on it, I'll have a few options. I can set it as my starting node, meaning this is where the pen tester may be starting on the network. I can set it as my ending node, saying this is where I want to get to. But I'm just going to go ahead and say mark group as high value. And I'll also want to say shortest path to here. That is one way to start saying, let's take a look at this and start exploring this network. From here, we can actually start diving in and asking a few other questions. So this may look familiar. This is one of the screenshots that I had before. And from this, you can start wandering away from domain admins and looking at what's all expected on here. There's other perspectives too from domain admins to say like, what are my direct members? Or what do I have local admin rights on? And these may be other areas in which you might want to explore. There's local admin rights. Okay. Where am I going with this? Let's go down the line of queries, because I think that's where probably some of these things that may have some initial and immediate value for you. Find logged in admins is a bit of fun. So we can start seeing where administrators are on the network. Top 10 users with the most sessions is a bit of fun. So we can start seeing where which users are touching the most machines. Those do represent sort of a pivot point in the pass the hash, the ability to pass the hash. Top 10 computers with the most sessions. These are where you find your terminal servers. These are also a hot point for the network. Top 10 users with the most local admin rights. So these are if I wanted to target any users, I would definitely try to target these guys. Yeah. I think that's all I've got for demos. You guys have any questions about what you want to see with any of this Bloodhound utility? Or I can start just exploring how that works.
Setup information.
Oh, good. Actually, that's actually a great segue. All right, let's do that. Back to this, all right. Because that happens to be the next slide.
Right
on call. Yeah, that's great. All right, so.
We'll let you ask.
Yeah. So the quick start guide, this is how I did it. It's not necessarily the best way to do it or the worst way. This is the way that I accomplished it, which was first and foremost, start with a Ubuntu machine or Debian or whatever your flavor of Linux is. It just needs to support Docker. And then the idea is that to install and prepare Docker, grab this GitHub repo, which the wonderful gentleman has prepared Bloodhound for you. Prepared Bloodhound in the installation process for you. And if we were to actually dive into this repo, which it's a ready-to-use system, he actually has a wonderful README to say, here's how you do it. So if I want to grab it from Docker Hub, this is what I would do. If I want to build the image, this is what I would go ahead and say. And when I want to run it, this is what I would do. There are a couple of caveats for this one, for following this method, which is on the next slide.
Can you copy and paste these instructions entered into command line each one?
You can copy and paste these, yeah, absolutely. Like, I mean, as long as you have copy and paste or command line access to whatever VM's running or whatever Linux box you have, yeah, you can totally copy and paste it. And that's basically what your goal is to do with this is for the Docker image, you have to build it and then you have to run it. So that's kind of the main thing that you're going to do. So, select one of the options for building it and then select one of the options for actually go ahead and running it. And this Docker repo also has the example data baked into it. Meaning that if I want to build the example data version of this container, I would go ahead and copy this command here, and that would go through the process of building it. And then when I want to run the example data one, I would then run this one here, and it says blood example.
So it was the example data provided by Bloodhound, or did this guy provide it through the Docker container?
I believe it was provided by Bloodhound,
okay.
For the Bloodhound guys, and we can actually dive into the Docker file, which is really, think of it as a fancy shell script, is the way I kind of think of how Docker files work. And we can actually go in and see where is blood example at. Control that.
Test data there.
Here we go. So there is all right. So it's this GitHub repo that they're pulling from. I believe is what they're saying. Pretend Bloodhound blood example. Yeah. So whatever's in this GitHub repo, and I will zoom in hand. That folks can see easily. They're pulling for whatever repo. It looks like a prepackaged repo. It's not generating it at build time. It's just a prepackaged example database that comes from Adaptive Threat. To answer your question. The additional edits to do Neo4j, I was throwing them in, I believe here, but they look a bit more like this. You have just appending lines to the Neo4j configuration file. So when it boots. When it boots, it doesn't list on localhost, and that causes a problem with Docker in terms of how networking works. But long story short, if you need help with that, I will totally happily provide those little bits of information. So, all right, the other little caveats that I found with doing this. Modern Ubuntu. Oh no, I didn't have that there. Shoot, I was supposed to put something else in there. My bad. All right, let me go back and show you what I did do. There is one caveat that I found to be a problem with Ubuntu, which was a modern Ubuntu switched to Wayland, and this works fine if you're in an X environment, but when you're running it as root in a Wayland environment, you had to change a local ACL to allow root to run displayed applications on your context. And that was a simple thing.
That affects Fedora.
Perhaps if it's running Wayland, yeah. And if you're running Wayland in its root.
What version of Linux are you operating?
1804. So the modern one, I think that's the first one that they started Wayland.
Real high level, what is Wayland?
Wayland is good question. All right. So back in the old days, let's rewind to the 90s, right? When graphical applications first started to exist in the network, yeah. Sorry, no, I don't mean. So we'll rewind to the 80s. There's a thing called X server. I just call it X. I don't know what it's called.
Yes, it's called
just X.
Yeah.
X server?
X server and X. Yeah.
X server and X. They're two different pieces.
Console and the server side.
Okay.
Yeah.
Console.
Do you want to talk?
No, that was back in like the 90s. I don't remember all that.
Okay. So what ends up happening, the thing that actually draws the bits on the screen in the graphical environment, that was your X server. And your X application is your window manager, I believe, or was what actually does the other components of saying, hey, this pixel here has this color, I believe. Am I slaughtering that?
I don't know.
Okay.
Something
All right.
like that, yeah.
So for some odd reason, we stayed with the same display system all the way from the early 90s, all the way up until 2017, 18, somewhere around that time frame. And there are problems with X. There are problems with it and how it works. There's gross details. And if you want to talk about asynchronous versus synchronous calls to display, we can happily talk about that. But Wayland basically gets around those types of things. Wayland basically is a more modern display manager, and it's sort of built with what modern applications like to use. That's my high-level sort of understanding. I understand a little bit from the asynchronous versus synchronous because of other window managers that I like to play with. But long story short, it's the new style of displaying apps on a screen. So it's the new style of displaying what's on display. Now the fun part is the window manager component, which is you'll see the GNOME on modern Ubuntu. On other ones, I think it's like LDE or LD. What is it?
Yeah, KDE is one.
Wayland is Ubuntu specific.
Wayland is Ubuntu specific?
Yes.
Oh shoot! What's the other one then?
There's Wayland and there's X11.
X11, but Wayland. I thought other things were speaking.
Ubuntu, they were using the Unity 3D engine.
Yeah.
Then they switched to the new Wayland
Gotcha.
engine. And
Okay.
everything else runs X11.
Okay. I thought other things were flipping into that. Oh, it's those Ubuntu guys ruining everything, aren't they?
It's just new stuff that they want to play with.
Okay.
Ubuntu and Fedora.
Okay. Okay. Thank you. Appreciate it. All right. Thank you for helping that. All right. So, that's Wayland. The thing that I had to do was set up a little bit. Maybe it's something that I probably shouldn't have been doing, which is background. I have a bit here. I have a startup script for this. The little bit that you wanted was this bit that's here. Zoom enhance, which is basically saying, hey, allow root to display on this page. There's other little bits that you can see referenced down here. These are what I alluded to adding into Neo4j, which is allowing you to listen on all interfaces versus on localhost. So this basically allows Docker to then publish components of Neo4j so that you can start preparing it. That's what it's all about. But I feel like we're getting into the nitty-gritty details here. But are there any other questions on that bit? Okay.
So you went out to GitHub and downloaded a Docker image, runs Bloodhound, and deployed it on the network and ran Bloodhound?
Kind of. So what I ended up doing is
You went out to GitHub
went out to GitHub.
and you downloaded a virtual machine essentially and put it on the network.
That's where I'm gonna trip
And
up.
that sniffed out all of your network connections. Okay.
What I did do is
Just checking.
I went out to GitHub. I downloaded a Docker file. And a Docker file is really basically, when you look at a Docker file, it's essentially a script. And we can actually then go through, audit the script if you wanted to, and see what it's actually doing. And then we follow the rest of that process, which is, yeah. But I did look at the Docker file, I looked through it, and that about as far as that went.
Do you have to run it in Docker?
You don't, absolutely not.
What would be the pro and con?
The pro and con is that if you run it with Docker, I find it personally to be a more clean install. It allows me to dump the container or refresh the container easily. That way, when I'm bringing up, say if I want to move to the latest version, I don't have to reinstall everything. Okay. I tell Docker, hey, give me the latest, and it will give me the latest.
Also, if you're sharing, if multiple people are analyzing it, you're all working in the same environment for sure. You don't have different versions going on. You don't have different,
Okay. That makes sense.
So that's why I went down the Docker route. That's why I found it to be easier, is because it's just less to install. I literally I go through and I run, let's see what the commands were. It was a git clone, or it was a git clone plus Docker build and then Docker run. So those three commands provide the UI environment, and then it will end up dropping the SharpHound executable within wherever you publish it at. And where I was publishing it was just directly to my desktop, because I also had a VM that was dedicated for Bloodhound itself. What else is there? I think that's basically, this one we can skip over. The point of this slide is that, hey, there's a dark mode, because every good utility needs dark mode. And so getting into additional resources. So the other fun bits that were wrapped into, or other fun bits that I found along the path. So Captain Jesus is absolutely fantastic. I believe that's CBT Jesus. I think that's Captain Jesus. Absolutely fantastic. And he seems to be the primary, the developer that's keeping things up and running, adding the new features. Whenever he blogs something, it's usually he blogs something about a new feature about Bloodhound. So whenever you're going back and trying to look at features that are there, you'll land on his blog and you'll read all about it there. Great guy, or at least great reading from him. There is a thing called the Dog Whisperer's Handbook, and it's a sort of a PDF you can go ahead and download. I think it was like 80 pages or something along those lines. And it's really, you don't want to read it like a book. You want to be able to look at the index, find what you're trying to do, and then that points you to additional resources. So this is where you can get ideas of, I want to run metrics, and that's where that handbook pointed me to the right resources to say, how do I collect metrics from Bloodhound? So this is sort of a meta book that kind of points to additional resources. And it really is just pointing you back to online applications. Not really call it a book, but more of a really good PDF that somebody did a lot of research and they pasted like, hey, here's a bunch of all the cool areas to go, all the pathways you could go down. There is also a Slack instance that all the Bloodhound developers and even there's a larger community that exists on there. The cool part about the Bloodhound Slack, the part that I've been finding value, is that there is a channel dedicated to cipher queries. And some people, you'll see people pop up and they'll say, hey, I'm trying to do this. And then somebody will pop in and say, yeah, this is the cipher query to do this. They're also building an extensive collection of what cipher queries are providing value and linking them back to GitHub. So it's kind of an interesting little resource that if you want to follow along what's happening live with Bloodhound, follow along in a Bloodhound Slack. That's where a lot of these bits are happening.
Are both pieces open source projects?
Yes. You can go in and look at code. SharpHound is one of those ones that didn't fully look at all the code, I will say. And it's the executable. There's the executable, which is C#, and then there's the PowerShell that's around it. PowerShell is just really an embedded executable and PowerShell around it. The other component, Bloodhound, is definitely open source because one of the dialog boxes that you will encounter is, jump back to this, under the information thing, you'll actually see authors, and then it has the MIT license on it. GNU license, sorry. On it. So this is open source.
Yeah, and there's a GitHub repository right there.
And then they even point themselves to Bloodhound Slack. Additionally, there are, I didn't pack it in here, darn it. There's also, the authors are wonderful. So they also have their own sort of respective users. Both Waldo, Captain Jesus, and Harmjoy are the three guys that are kind of doing all this sort of stuff. Harmjoy had the original sort of, they did a lot of work with PowerShell and tried to get information out of PowerShell. I think it was, I forgot what the name of the tool was. And that sort of enabled some of this capability. Waldo extended on it, and Captain Jesus actually wrote out the entire tool. That was my rough understanding of this whole thing. But those three guys get the credit for writing this.
I see the image keeps actually going back to the Bloodhound. Where does the name of this come from? From the actual Bloodhound?
I actually don't know. I have no idea where the name actually came from.
I have a Bloodhound. I see this and I keep thinking about my dog at my house.
Okay.
I guess that makes sense. He's dipping out the path. He finds.
That's what Wayland does.
Yeah. And then SharpHound was written in C#, and that's why it went down the round with SharpHound. That makes sense. All right. Cool. Oh yeah, this is where the things are at. So yeah, but I guess at this point in time, is there any questions? If not, okay. Yeah.
How much did you play with the cipher and the VO?
Not too much.
Whatever.
So what I ended up doing is that I fired up within that Docker container. I threw a command shell into it. I also got Python in there, and I started playing around with Python until I realized, oh, there's an even easier way, and that's WebGUI.
Okay.
Basically, I was trying to do just simple counting commands. That's what I was trying to do initially, and then I found the Slack channel all about cipher and the Dog Whisperer handbook. I probably went a little more on the manual side, trying to figure all this stuff out, and realized there's already a ton of resources out there already. So I spent probably too much time, I guess, is the answer. Seeing what already is out there is probably more important than just learning it for myself.
So what can you access through Python?
So I mean, Python, you can actually connect to Neo4j, and so you can just start querying the database through Python. It's much easier to do that through the through the provided web interface.
Right.
I just thought of it like every other database, and that you needed some sort of, like language to actually to actually get in and access it. Not the case. You can actually, it comes baked in with an IDE. I can even show that if you're interested. So, all right, thank you. Any other questions? All right, well, thank you so much. I'll show you afterwards.
No.
All right. Well, thank you so much. I appreciate it.
Appreciate it, man.